Now let's look at example 3, version B. Version B is very similar to version A. The only difference is in version A, the part-time is 4-hour shift, but in version B, 3-hour shift. So what I would suggest is you can try version B by yourself first. Then after you're done, you can watch a video to compare your solution. So the procedure-wise is very similar. So let's say you already tried it. So how can we do it? So the column B shows the number of people needed for each hour. And I also I have 2 full-time employees. This is a working schedule for full-time employees. So column E, I want to calculate the number of part-time employees I need to hire for each hour. So what you need to do is update. Will be 9. I have 1 full-time employee available. Subtract 1. Second period, I have 1 available as well. The next period, I have 2 available. Next period, I have 2 available. Next period, I have 1 available. And then 2 available. And then 1 available. Next one, I have 2. Next one, I have 2. And next one, I have 1. So that is update. I just want to calculate how many part-time employees I need to have for each hour. Then column H shows the shift. Okay, look at here. I have this now. It's 3-hour shift. It's from 11 to 2, 12 to 3, 1 to 4, 2 to 5, all the way to 7 to 10. So these are the possible shifts. The green numbers, these numbers are actual numbers are high to cover each shift. So in the previous examples, I always started with something. It's called initial solution. As I said, these numbers are not important because eventually Excel will change all the numbers. So in this example, I'm going to leave these cells blank. I don't want to fill anything. It doesn't really matter because eventually all the numbers will be changed by Excel solver. So I leave these cells alone. I don't want to change anything. Leave it blank. It does not affect your final solution. What I need to do is based on column H, I need to create column F. So if this is the number of people you're going to hire for each shift, I want to calculate how many people are available for each hour. So based on this, I want to create a formula to calculate this. Let's look at the first hour. So who's available from 11 to 12? So from 11 to 12, this is the person who's covering from 11 to 2. What about a second one? From 12 to 1, so who's available from 12 to 1? From 12 to 1, this person plus this person, so from 12 to 1. So who's available from 1 to 2? So 1 to 2 is this plus this and plus this. So these 3 shifts, they all cover the period from 1 to 2. About 2 to 3, the 2 to 3 will be this one plus this plus this. Now the first one. Look at the first one, the first shift from 11 to 2. So 11 to 2 does not cover the time period from 2 to 3. So you can do this for the rest. Next one. The next one from 8 to 9. So who is covering from 8 to 9? Will be only 2 shifts. These 2 shifts will cover the period from 8 to 9. So who's covering from 9 to 10? Only 1 shift, the last shift from 9 to 10. Then we can calculate. So based on the number of people we hire for each shift, we can calculate how many people we need to hire in total. So total number of part-time employees, the sum of all the people here. This is total number of people we need to hire. So based on the total number of people we need to hire, we can also calculate the last one, total pay. So how much we need to pay them. So will be the number of people we need to hire times each part-time employee will work for 3 hours only, remember. So this is 3-hour shift. So each person will be working 3 hours a day times the hourly rate, which is 7.5, the same. So that's the total pay. Of course, now it's 0 because I haven't filled anything yet. So eventually these numbers will be changed by Excel. So now we have the table available. We're going to use Solver to solve the problem. So click Solver. The objective is this one, total pay. We want to minimize it because we are the restaurant manager. By changing variable sales, all the green numbers are the variable sales. And then constraint, I have one constraint. So which is column F. That's the total number of part-time employees scheduled for each hour has to be greater than or equal to the number of people needed to one constraint. So before we solve it, we want to choose the right solving method, which is simplex LP, then click solve. So now we have a solution. So this is a solution. We're going to hire 8 people working from 11 to 2, 2 people working from 2 to 5, 10 people from 5 to 8, and 6 people working from 7 to 10. So total, we're going to hire 26 people. Because we're hiring 26 people, we'll end up paying $585 per day. That's the labor cost per day. If you look at constraint, the first hour, we have enough, second hour, enough, the third hour, the fourth hour, now we have 1 people extra, okay, 1 extra people. As I said, there's no way you can do perfect match. If you are comparing version B and version A, you will see version B end up with a lower cost. For version A, if you have to hire 4-hour shift, you will end up paying $600 per day. But with the version B, if you only hire 3-hour shift, we only pay $585 per day. That's the labor cost.